Hi everyone, I've got a bonus video and bonus problem for you here because I thought it would be fun if I showed you what happens when A isn't equal to 1 and B isn't even. It's odd instead. And as I got into this, I'm like, I don't think this is actually very fun. Well, maybe it just depends on your definition of fun. But here we go. Let's go ahead and look at this. So here is my equation. Notice that my A value is 2 and my B value is -5, so it's odd. And this method of completing the square only works if we have a 1 in front of our x squared term, a 1 for A. So I immediately need to get rid of this 2, and the way to do that is to divide everything by 2. But because I have some odd numbers, whenever I divide by 2, I end up with some fractions. But we can still do this. Remember that C is equal to half of our B value, and then after that, it is squared. So half of our B value is going to be -5 over 2 and then divided by 2 again to take half of it and then square that. So we get 25/16. We can take 25/16 and plug in our C value here and here. Now we have to come up with our binomial that's squared. And remember that I take half of the B value in order to get this value, so that's going to be a -5/4 squared. And then over on this other side, I need to combine my fractions, and so I notice that 16 can be a common denominator. And if I have a common denominator of 16, I get 16 by multiplying 2 times 8, which will give me 24. 24 plus 25 gives me 49 here. So now I'm ready to take square roots. All right. So luckily for us, this is a nice perfect square. It's the perfect square of 7 on the top and the perfect square of 4 on the bottom. So at least that works out nicely for us. Now we move the 5 over 4 to the other side, and we even have a common denominator. So that works out nice as well. And I find out that x is equal to 3 or x is equal to -1/2. Now, that takes a while to do. It requires adding and multiplying and dividing fractions. Here's what that same problem would look like if you used just the quadratic formula. So notice that this looks much more simple. We have the one big fraction that we're dealing with at the entire time, but we're not having to divide, multiply, or add fractions. And of course, we get the same answer. So this would be easier, but it's not impossible to do it with the completing the square method.